Yeah, I have the honor to give the last talk of the day of the conference, and I would like to speak about what we see at Seerene, because we provide analytics to organizations that do software development, and what we see, what the concrete hurdles, the concrete difficulties are for these organizations to, that they fight with on their way to achieving higher software excellence. And today we have already heard a lot of different kinds of facets, different kind of strategic objectives you want to reach in the automotive industry to become better, to acquire more, a better, efficient, more excellent way of doing software development. What I'm speaking about is actually a little bit broader, because software development is not only relevant for the automotive industry, but for nowadays actually any industry, banking, insurance, logistics, everywhere software is important, and the ability to build tailor-made software systems, so the ability to do software development. So this is one thing. I want to pinpoint the what we see the major hottest topics are that needs to be solved in the organizations, and also we want to provide some information, some hints, some tips, what we see, how this journey could be a little bit smoother if you use data that is already collected in your software development infrastructures and make it useful, bring it from the data level to an information level to something useful for management, but also for the teams, so that these hurdles, these difficulties can be pushed away. So I would like to start with the general difficulties that organizations have. I already said software is a strategic asset nowadays, tailor-made software system, strategic asset for every kind of organizations, and it has become the foundation for the business. And this picture here looks a little bit like IT, right? The business runs on top and the software is foundation, but it also includes software in a car, any kind of software that you need to grasp business opportunities. And one of the big now what we see now, organizations, software development organizations, the organization inside of the big corporates in the companies, most of them are now at the point where they ask themselves, how well are we already doing now? So it's about how can we quantify our level of excellence. And there's one specific topic in it, which is of high interest, which is how efficient am I? How efficient do I use, for example, the most scarce resource that I have, which is developer time, right? We heard this in the morning and throughout the day that there's a fight. Every company wants to get the best developers, so it's a very scarce resource. And the question is, how can we measure efficiency? Because if we measure it, we have the ability to optimize, right? Like in hardware production. So this would be one point. I will go into details. The next thing is, this is something which is also broader than automotive. This is everything outside, every software outside the car. And here we see this shift from waterfall projects, from engaging system integrators or giving away the software, but doing it in-house, because if software becomes a strategic thing for an organization, then you need to have the competence inside your organization. So it means you need to build up your own in-house competence, And most of the organizations do it in an Agile ticket management system, Jira, etc. So all these two, and then a lot of static code analysis like QAC, Kubernetes, etc. So this is all existing. And what we now make use of is that if there's work being done in the software factory, these tools produce data traces. And we take the data traces and fusion them and convert them from technical data to management relevant information. And the fusioning is actually the most important part, because the information does not sit inside of one of these tools. It sits if you bring it together. So then you can say something about the process. For example, you can take the anonymized footprints of the developers in the version control system, where the code is being hosted and the code changes are synchronized technically, and then you can reconstruct the flow of time. It's no time tracking, it's just taking the data traces, right? And then, for example, if you have a software system and there are 10 developers, it would be €1 million salaries, more or less, every day. If it's 100 developers, it's €10 million flowing in there into your factory. And the key question now would be, how much of this time can be used for value creation? And if you measure that, then it's always, it's our experience, no matter what kind of level of excellence the organizations have, usually there is a lot of loss on the way from the input time, the money that you spend, and how much of the time you can really use for value add. It's things like technical depth. So code has become complex. And now, if developers have to touch this code again, it's paying interest on technical depth. It's losing time, right? You can quantify that. Or if defects are hopefully found, they need to be fixed. So again, the precious developer time has to be taken for this and is not left for business value creation. To this one, I come back later here. So this is one thing you can do. You can measure. And by the way, it looks a little bit as bad news, right? 100% input and just 20% useful for output. A lot of loss. Sounds bad, but actually it's a good news, because it means there's sleeping potential in your organization, right? So that you can, if you see the root cause, if you see where it comes from, you can convert this into extra time. And this converting is supported if you do analytics one layer deeper. And what you can do is you can project, now for example, the amount of time which is spent for defect fixing. You can project this and ask yourself, where in my code architecture does that happen? So where are the hotspots in my code architecture where defects come in all day and the developers have to burn their time and your money with that, right? So this is a visualization that we use here to depict source code, how the system is being built. It's the modular structure of the system automatically generated. It's like how developers think code, and the buildings are code units, could be C or C++, could be Java, could be SAP, ABAP, right? Any kind of programming language. And it's you look at code, but you project developer time into that. That's the key. It's not just code analysis, it's looking at some management relevant information, now doing the drill down and see where can I do actions, where can I solve the problem. So it's also a very, very important thing. It's not, a good thing already is if you are able to measure in terms of KPIs. If you can measure what's the trends, what's my situation, what's the trend, am I getting better, am I getting worse? First step, very important. Next step is that you can drill down and go to an operational level and say, what can I do? And also important, I don't want to replace the entire system. There's no time, no money for that. What can I do? Very specific, small improvement actions to improve the situation. And very, very important, and then the cycle is closed, you need a means to measure, once you do these small improvements, you need a means to measure the impact. Does this improvement action really creates the impact that we want to have? And this is also the way how you can integrate all the expert knowledge on the team level here. Because it's like OKRs. You want to achieve a goal, and the teams can define we want to do this small action here, but you close the loop that all the operational actions really, you see if they 100% go into the strategic direction that you want to achieve. So this is one of the general things we see in all kind of software factories, the ability, or until now, the question, how can I measure, how efficient am I, and how can I get better? Now, the next part, the next major difficulty that we see on these organizations who have become or switched their model from waterfall to more agile style of doing the work, and specifically agile style. This is a simplified way of showing how software development is done, right? It comes from the requirements, the business topics. Then in Agile, the speak would be features being broken down to stories. Then there's the backlogs. Then the developers, the teams take the backlogs and bring the requirements into the existing code base. Here, by the way, the ops parts is not on the screen, would be on the right-hand side. And we also heard today about handover points, which are critical, and this is one of the critical handover points. In an agile team, you would have a product owner who is sitting here and the engineer, so that would be one team, but still there would be the handover point inside of the team. And this is usually a problem if you cannot measure how much is really going through this handover point. And what do I mean with how much? How much of the developer time, again, the scarce resource developer time, how much of the developer time is just being done without any work items? Right? This is you find it, unfortunately, a very low mature way of doing Agile, or generally development, that developers just do without any work items that comes from the business side. And with analytics, again, you can quantify how much of the percentage of the developer time is that kind of below the radar work. The other part is, and this reflects a learning curve in such agile organizations, and the learning curve is on the product owner side. Usually, Agile is not a DevOps problem. It's a biz DevOps problem. It's the capabilities of the product owners. The product management side, the product owners, do they have a big picture, a big business picture? Do they have epics, a vision, epics, features, and then derive stories from that? Or do they just fill this backlog in an ad hoc style, which is not the best way to doing it? And again, you can quantify that. And bringing this into the picture, this is the last part of this efficiency graph, this flow graph that I've shown to you. This part here reflects a low mature way of working in an agile organization on the product management side. And most of the agile organizations that we look into it, they have a significant amount here of inefficiency, which means the DevOps part, the engineers are already, this is somehow solved. They have good tools. They have blueprints, how to do the job, continuous integration. This is mostly solved, but the product owner side, the business side, this is oftentimes still not on that maturity level that it should be. And it's an efficiency, because it means this amount of time does not flow into steered business features. Now I've jumped to topics around embedded software. This is now specific to the automotive industry. And what we see here is also a broad range of how development organizations operate. And on the left-hand side of that range is this project thinking in its purest way. Means there's a project 1 or A, and then a follow-up project is being started, and it's being started by the expert developers who take the code or look inside of the code of the last project and pick the best pieces of code and ramp this up, right, for the next. So it's a kind of evolution, but it's from project to next project to next project. And it has a lot to do with knowledge of these expert lead developers who know what to pick. In a better case, it's not just picking, it's like taking the project and evolving that. And here, by the way, going back to the efficiency number, what you could already do here is measure the efficiency of each individual project in the way I showed to you, how much of the developer time can really be used for value add. And this already gives interesting information about how well these projects are being performed. And you can do this, by the way, across departments, across divisions. So you have something that you, and different kind of projects of different types. So it's a way to be able to benchmark or to compare your own organization and see where parts of the organizations are already doing a really good job and other parts not so good, but they could learn from them. So it's a means to trigger some best practice sharing inside of your organization. So from here, a better way to do it is to really make reuse tangible. And this is, we already heard, this is what you usually call platforms. It's generic code components where you strategically invest. So the investment, the new functionality, is strategically put in here. In finance speak, that would be the value creation. And the projects then is the part where you earn the money, the value capturing, right? So this would be a better way to have that reuse part and use it in a systematic way, because if you do it really good, it means you can earn money much easier, because you can reuse a lot of these functionality. The question is, how do you get there, and how do you see what's my level of reusability? How do you measure that? And one way to measure that would be to measure the amount of coding effort that is necessary on the project level. So a perfect project would be you just take the 100% reusable components, put them on the level of your project, maybe a little bit glue code and some configuration, and that's it. And money, right? So earning money. But if you have a lot of coding on top here, it means that these components were not 100% reusable. So one indicator for a project that, or for a project where the components are not so reusable is a lot of amount of developer time spent here. And now the question would be, okay, how can I get better? Again, drill down to these code landscapes, code map views, because here you would see the project code, all these components here, but you would see where these which specific code units in the components needed to be adapted, to be reshaped in the project context. And this is very helpful information for the ones who own these components, because they see, okay, my component in all these projects, in these areas of my code city, there's a lot of reshaping necessary. So a good thing would be if I took my component and bring these generic functionality in here, so that on the project level, these additional extra work would not be necessary anymore. So that would be the way to systematically drive to more and more reuse. The last part, this is, again, embedded software, but now in this software-defined vehicle context. And we already heard today, it's not enough just to take to build the software variant for this specific hardware or customer. If it's a tier 1, it would be a hardware or customer project. It's not enough just to deliver that. It's much more, because software needs to be updated. So it starts with the same picture as before. You have the generic code components. You create your project on top, and the other variants, right? And at the end, a lot of variants that you have to maintain, which is a nightmare in terms of and actually then a cost explosion, because you have to maintain all that. A project is not a project anymore. It has no end, right? And it's even worse if the code on the project variant area deviate from the generic code components. Why? Because the whole idea of software-defined vehicle is to be able to bring in innovation here every day, every week, every month, and shift this innovation to the cars, to the code in operations, in real-time use. And if the project variants in the cars have deviated from the generic code, and we heard this in the other talk, then it's not easily possible to update the code here. It will break, and you have high integration costs here. And with analytics, you could do the following. You could measure the amount of deviation of a component in its project variant compared to the generic components. So, for example, here it's over the time. You see, in terms of lines of code that would need to be patched to converge those. So now you have a means to see how far am I away, and can do strategic actions to come closer. And it's not only that you see the trend and how far you are. Again, with the code maps, you see at what parts of the code architecture that happens. So it's, again, on the level of the operational level on the teams, they can precisely see where in the code they need to converge, where the project variant should be brought to the generic variant, or vice versa, that the generic component should offer the functionality that is necessary up here in the project context, so that you bring these two things together again. And by the way, usually it's not possible to linearly converge it, because you have to deliver in the project context. So it might happen that you will deviate at some point, because you need to be quick here at some point, but you need to know that, and you need to be quick then again on the generic component, so that these you do the work here first, then you shift it down. So, but you always have to be sure that these two lines do not deviate again. And this is then the prerequisite, by the way. This is the hurdle, the first step. And it's much more, as you heard today, right? But this is a prerequisite, and it's not easy already, but you have to fix that as the first thing to be able to deliver code into running cars, because if you have this deviation problem, you have no chance. And then, then you have the ability to continuously create innovation and provide it to all these different car and vehicle models. So, to sum up, I've now pinpointed 4 concrete challenges. I wanted to be very pragmatic and very hands-on in this talk, because I knew there's a lot of strategic directions or was today in other talks, and I wanted to pinpoint really 4 things that nearly every organization encounters, and every organization goes through the same learning curve somehow. And give a little bit hope on that, because with analytics, with the data that you already have, these learning curves can be shortcutted somehow a little bit, because if you see in a data-driven approach, it's like a navigation system throughout these learning curves. And the biggest issue is efficiency. How do I measure efficiency? How do I make sure that all my activities in terms of software excellence really have an impact? And this is something which can be done in all kind of software development. Could also be a core banking backend. And this challenge here is about Agile, typical Agile challenge, and the others are pure automotive context. And we also saw today different stages. Some companies came very from the hardware side, not yet really integrated, or the software part was small. And this, by the way, would be first one I had in some talks in the break times, where it was about, we are doing a lot of projects, right? But the question would be, how can we establish reusable components here? If we have done the same kind of project 3 times, then the 4th project, which would be similar, wouldn't it be good to have some kind of reusable platform or components to be more efficient? So this is what I focused here with that challenge. And the last one is, I think not everyone is here yet, but if you are here yet, if you really deliver 4 software-defined vehicles and you have that variant problem that Bosch has described in his talk, then this is very relevant. So with these, I want to close, and thank you for your attention.